Thank you very much. And the talk today has been really prompted by, I guess, the mantra that a lot of us have heard over the last couple of years: follow the science, follow the science, follow the science. And that means different things to different people. And so I thought it would be useful to actually take a look at what that might really mean in reality and what it might mean to different groups of people. So, you know, Dr. Fauci, obviously, and I don't know if you can see this clearly from the back or not, but Dr. Fauci, as everyone's familiar, said, as you get more information, it's essential that you change your opinion because you've got to be guided by the science and the current data. So the whole idea of the phrase, follow the science is presumed to be reliable information. And so we want to kind of unpack this because that actually sounds very straightforward, but it means different things to different people. So we're going to talk about what is science, what science is not, science's limits, where science is silent, does science lead, or do we use science? And where does science point? So I thought we would start off with just a simple definition. And of course, if you're talking about science, where do you start? Einstein. So to Einstein, science was basically an endeavor to pursue the truths about the perceptible phenomena in this world. So it's an endeavor of discovery. To Jerry Coyne, who's a biology professor at University of Chicago, it also is an endeavor to pursue knowledge, but specifically using the tools of reason, observation, and experiment. And the result of that, obviously, is a body of knowledge. Now, in the 1700s, they were calling everything science, okay? So the 1600s, you had the Age of Reason, you had the Scientific Revolution. So everything was being called science, and the reason is because the word scientia is a Latin word meaning knowledge or science. Everybody was pursuing knowledge. Okay, so they tended to use the word relatively generically. And it was also the mindset of, we want to approach these subjects in a structured manner. Okay, so given that, a lot of subjects were being called science. So for example, John Stuart Mill, who's a philosopher, into utilitarianism. He called utilitarianism the science of ethics. So he was seeking to turn ethics into a science. You have other people calling political science. Well, I studied political science my freshman year, and I really didn't see that much science in it. It's just, excuse me. But you can see why people were calling a lot of things science. Today, what we generally refer to as science are the natural sciences and applied sciences. And it's not that these other disciplines don't use a methodological approach or a systematic approach, because a lot of them do. A lot of them will use the tools of science, but they're not studying the physical universe, okay? And so that's really kind of the differentiation where most scientists would put it. And back in the day, mathematics was called science, but today, people like Richard Feynman would insist that, well, it's really not science, it's a tool of science, but it's not science. So is science the only way to know things? Okay. How do I know that my wife loves me? Is it through science? It's through personal experience. How do you know what happened yesterday? Okay, you might read a newspaper, you might look to journalism. How do you know what happened 2,000 years ago? Well, you might look to history or archaeology. And all that's valid knowledge, right? Okay, there was a tendency, especially in the kind of the late 1800s, to insist that if things weren't derived by the knowledge of science, it wasn't real knowledge or it wasn't really reliable. And Robert Ingersoll was a great example of this in the late 1800s. He says, is there any other kind of knowledge than scientific knowledge? He's insisting that really science is the only way to find truth. You had Bertrand Russell in the 1900s who basically said, whatever knowledge is attainable must be attainable by scientific methods, and what science cannot discover, mankind cannot know. That sounds kind of extreme. And then Alex Rosenberg, who's a philosophy professor at Duke, softens it a bit, but he still says that science is the most reliable form of knowledge. Okay. Ian Hutchinson, physics professor at MIT, would take exception to that. Okay? And what he says is knowledge is not one-dimensional. It's not arrived at by anyone's strategy or method. The methods of natural science, while uniquely powerful in their chosen domain, are not applicable to much of the knowledge we know. So you have different views on really what is the best way to know anything? Is science the only way to know it, or are there other valid ways to gain knowledge? But let's talk about what science is not, okay? Science is not a worldview agenda, even though there's a small percent of scientists that really tried to make it one, okay? So for example, Ludwig Buchner, who is a very prominent German scientist in the late 1800s, early 1900s, said science must take the place of religion. He literally wanted to usurp religion and replace it with science. Jerry Coyne, who's a professor, again, at University of Chicago, just a few years ago said, indeed, the progress of science has required the shedding of all vestige of religion, whether those be the beliefs themselves or religious methods for finding truth. And Steven Weinberg, a Nobel Prize winner in physics at UT Austin, said, anything we scientists can do to weaken the hold of religion should be done and may in fact be our greatest contribution to civilization. That sounds kind of harsh. Mario Bunge, who's a professor at McGill in Montreal, took it one step further, and he said religion should not even be taught in universities because it hinders your scientific perspective. So there's a small group of scientists who basically have a worldview that they are trying to promote, but really, when you look at it, that's not what science says, because that's not the subject of science. So for example, Richard Feynman, physicist, atheist, Nobel Prize winner, says that science and religion are consistent. Max Planck, Nobel Prize winner in physics, says that they complement each other. Stephen Jay Gould, very prominent biologist, said that they're compatible. Ian Hutchinson, MIT plasma physicist in charge of their nuclear fusion research at MIT, says that they're not contradictory worldviews. And Freeman Dyson, who's a physics professor at Princeton, said, I see science as a way of exploring the universe with a limited set of tools, and religion as another way of exploring it with a different set of tools. So even some of the most prominent scientists on the planet really don't see religious belief and science as inconsistent. Though a small group may believe it to be so. Because science and belief in God need not be in conflict. Okay, next question for you. Does science, because again, remember, we have to follow the science, but does science lead or enable? Does science lead you somewhere? Or do you learn, or do you take all of the things that science has illumined and the knowledge that we've gained through science, and do we use it? Does it enable us to do things? And my contention is science is wonderful, but science doesn't actually tell you to do anything, okay? You take what science teaches you, and then you make reasoned conclusions and plans and purposes based upon what you've learned. So as an example, we've had all these amazing inventions using applied science, but not all these amazing inventions have been used in the most amazing way. Okay, a few more things. Science, as wonderful as it is, and as much as we learn from science, okay, is not infallible. And the reason it's not infallible is because it's provisional. We're always learning something new. And it seems like probably once a month you hear in the news, you know, we learned about X, Y, Z, and it changes everything that we ever knew about so-and-so, so-and-so. Okay? And that's true, it did change it, because we now know more. And that's one of the challenges with science, is you've never arrived. You've never learned it all. There's always more to learn. And so what you think you know may be factually true, but it may be an incomplete picture. So when you're saying follow the science, just be aware that you might be following an incomplete picture of reality, not the full picture. It's provisional, but it also includes assumptions. And this was really interesting to me. This is Richard Lewontin. He was a biology professor, I believe, at Harvard. He said, science consists not simply of a collection of true facts, which it does, about the world, but the body of assertions and theories about the world made by people who are called scientists. It consists in large part of what science says about the world, whatever the true state of the world might be. And I thought that's interesting, and I thought, you know, that makes sense, because when I was young, there was a huge emphasis on the word hypothesis, okay? And a hypothesis was an idea that didn't become a theory until there was substantial evidence to support it. And then it became a theory. And they knew that that theory might change, right, as you learn more, and that theory might be fine-tuned, and that theory might even be proven false, okay? But one of the challenges today is a lot of things are being called theories that have really no evidence at all. And so science, you know, as Lewontin had said, doesn't just include true facts, it includes assertions. And in some cases, it includes what scientists want to be true, really whether it's true or not. And then finally, it includes the pursuits of the non-empirical. And I thought this is interesting. Okay, you know one of the challenges with string theory is? String theory is based on the premise that there's 11 dimensions. But we have a really hard time proving that there's 11 dimensions because we're bound by 3 spatial dimensions and 1 time dimension. So how can we, in 4 dimensions, prove 11 dimensions? So they really are limited to what they can do with mathematical models, but they can't actually prove it beyond what a model might suggest. And guess what? Scientists aren't perfect. They're just like the rest of us. They're not infallible. You know, they don't always agree. You know, during the 1900s, because of the theory of relativity and quantum theory, physicists were just like in an uproar. They were at each other's throats. And because of the push upon university professors to publish or perish, there's actually a real challenge today because 50% of the papers that are published, they can't replicate the results. And so they can't replicate the results with the same data in many cases. And that's a real challenge. And I think that they're just putting way too much pressure on professors to put out papers, and they're not doing the quality of science that they really need to be doing in some cases. And then Richard Feynman, Nobel Prize winner in physics, just came out and said, hey, scientists lie, which I thought was kind of interesting. Again, scientists are just people. And science's tools are finite. We can't learn everything about the universe because we just don't have the tools to do it. They can't figure out if there's a quantum theory of gravity because you know what? We don't have any tools to figure out how gravity could be felt at a quantum level. There's no conceivable way to develop a tool or a measurement to do that. Science is also silent about some things. So I don't know if you realize this, but science doesn't have a moral code. It doesn't have a moral code. It studies physical things. It studies what is. It doesn't study what you should do with it. So this is according to Einstein. Science can only ascertain what is, not what should be, and outside of its domain, value judgments of all kinds remain necessary. Science doesn't say that you have value as a human being. It just says you're a human being. Okay? Feynman, also Nobel Prize winner in physics, said, ethical values lie outside the scientific realm. I have to defend that because many people think the other way. They think that scientifically we should get some kind of conclusions about moral values. And Steven Weinberg also said science can never explain any moral principle, period, because that's not the domain of science. It's not a fault, it's just that's not what science does, okay? So in the case of both Einstein and Feynman, where did they look for their moral codes? And it's interesting because Einstein is a deist, Feynman was an atheist. And they both looked to Christian morality for their moral codes. Feynman said Western civilization was built on Christian ethics. The basis of action on love, the brotherhood of all men, the value of the individual, and the humility of the spirit. Einstein said that Western civilization was based upon it as well. And then finally, science can't answer why, but it can't answer how, okay? Science is great at answering how, okay? Science can tell you how things work, but they seldom can tell you why things work. So for example, Lawrence Krauss, again physicist, he wrote a book called Why Is There Something Rather Than Nothing? Okay? And I read his book twice, just to make sure I really got what he was saying. And he started off by this intellectual ascent of the mountain of why everything exists. And literally within the first chapter of the book, he said, well, when scientists say why, we really mean how. And so he literally, in the first chapter of the book, he switched mountains. Instead of the mountain of why, he answered the mountain of how. And he basically said, when we ask why, we usually mean how. If we can answer the latter, that generally suffices for our purposes. And again, Owen Gingerich, astronomy professor at Harvard, basically said the same thing. Science can answer how, but it really can't answer why. So here you have it. Let's go to Gottfried Leibniz, late 1600s, early 1700s. He asked the classic question, why is there something rather than nothing? For nothing is simpler and easier than something. Now think about that. What could cause nothing to become something? And hold that thought, because that's where we're going next. Science can't answer everything, as wonderful as science is, as insightful as science is. But science can illumine and science can point, okay? That's some of the things that science are really good at. It illumines and it points. And one of the places it points is to a beginning. Again, the mid-1800s, especially in Europe, there was a big idea, two big ideas. One was, because the conservation laws of mass and the conservation laws of energy, energy can't be created or destroyed, and matter can't be created or destroyed. If it can't be created or destroyed, it must be eternal. And if matter is eternal, we don't have any need for God. Ernst Haeckel took it one step further. He related it to biology. And he applied, at that time, Origin of the Species had just come out, and so they're going, wait a minute. If simple things become complex because of nature, then wow, nature is responsible for its own existence and its own complexity. Okay? And if nature is responsible for its own existence and its own complexity, creation is myth and God is too. So, Lawrence Krauss summed it up. Basically, late 1800s, matter was viewed as eternal, it was viewed as infinite, there was no need for God. Until something changed. And the big change was about 1962, I believe. 64. Okay, Owen Gingerich, astronomer, Harvard. Neil deGrasse Tyson, everybody's seen him on TV, astrophysicist. Lawrence Krauss, physicist. Christian, atheist, atheist. They all say the same thing. The universe began. Now, we know this because guess what? Scientific evidence points to a beginning. It was one of the first guys to theorize it was Robert Julius Mayer in 1814. And he, based upon the dispersion of thermal energy, he theorized that, wait, yes, because energy dissipates, there had to be an original source of that. And that original ultimate source he called the cause. Okay? He was ridiculed, they wouldn't publish his paper. And then guess what? Einstein came out with the theory of relativity, and Georges Lemaitre did the math. And he said, wait, Einstein, based upon your theory, the math suggests that the universe began. And he went on, Edwin Hubble actually observed, because of the redshift of light in planetary systems, he observed that the universe was expanding. Then Lemaitre then did the further math, and he goes, wait a minute, all this started in a singularity. In other words, there was nothing, and then there was something. And it's like, wait a minute. But they didn't know for sure. They thought it was true, but they didn't know for sure until 1964, Penzias and Wilson, they discovered the background radiation of the Big Bang. They got the Nobel Prize for it. The universe began. And since then, scientists originally thought the universe was about 13.8 billion years old. Now they say it's about 11.4. And the first mature galaxies evidently appeared within 270 years of the beginning of the universe. If you put that on a 24-hour clock, there were mature galaxies within the first half hour of the universe. Mature galaxies. So not only did the universe begin, it matured rapidly. That's what science now says. But how could a universe begin from nothing? Three options. Either it was an accident, some accident caused it, it was a necessity, some law caused it, or is a decision. So Peter Atkins, chemistry professor at Oxford, has a very unique perspective on this. And this, believe it or not, is a real quote from him. This is from his book on Being. He said, at the creation, nothing did indeed come from nothing, but the original nothing was turned into a much more interesting and potent current nothing when some kind of event split nothing into electrical opposites. Wow. Okay. Stephen Hawking said, well, no, it wasn't like an accident. The universe had to create itself from nothing by necessity. And he said, because there's a law like gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there's something rather than nothing. Why the universe exists, why we exist. But Stephen, time out. If there was nothing, how could there be a law? How could there be a necessity? How could there be an accident if there's nothing? Lawrence Krauss, he's an atheist. He does not believe in God. But he's intellectually honest enough to say the apparent logical necessity of a first cause is a real issue for any universe that has a beginning. Therefore, on the basis of logic alone, one cannot rule out such a deistic view of nature. In other words, you can't rule out the fact that God did it. Okay? You can't rule it out. So he doesn't believe that God did it, but he's honest enough to say, I can't rule that out. And Steven Weinberg acknowledges that a beginning is a lot of comfort to people who believe in God. Okay, so universe began. Necessity, accident, or decision? Well, people who don't want to go to where these three things might take you, have come up with some novel theories. So again, Peter Atkins, this one is a mind blower. And this is a real quote, okay? He said, "It might be the case that any universe can bud into an infinite number of universes. And the current number of universes is already infinite, but increasing, and possibly increasing infinitely rapidly at an infinitely accelerating rate, and has been accelerating infinitely rapidly for eternity." I'm going, excuse me, I thought infinite meant infinite. How can infinite grow infinitely fast? Okay, but you see what he's doing? And he's a very bright guy. You know, he's an intellectual giant, but he's grasping at straws because he's trying to figure out, he is so wedded to a materialistic view of the universe that he can't allow himself to go to the possibility of God. Then you got quantum fluctuations. And Eddie Tryon, I don't know if you ever heard him, he was a professor at Hunter College. He came up with this idea back in 1973, and he was absolutely pilloried for the idea. He published it in Nature magazine. And ironically, many, many physicists are now embracing his idea that they ridiculed him for back in 1973. His idea was, because in a vacuum, from time to time, okay, you can create a vacuum, suck everything out of it. And what will happen is an electron, a positron, and a photon will appear seemingly out of nowhere, and then they'll immediately annihilate each other. It's called a quantum fluctuation in a vacuum. And it happens, okay? Not frequently, but it's been observed, okay? Now what he said is, what if you supersize that? Maybe that's what happens to universes, and they just happen from time to time. But again, the problem is, and he admitted this, it presumes that there's already pre-existing space and a pre-existing universe. So it's not really a beginning from nothing, which is what science currently observes. And then finally, Victor Stenger, bless his heart, physicist at the University of Hawaii, chooses denial instead. Okay? I don't like where the evidence takes me, so I'm going to just deny it. I'm going to say the universe probably had no beginning. You're a scientist. Deal with the evidence. Don't ignore it. Don't deny it. You're being a science denier. Okay? So what all this does is you go, wait a minute, let's go back to Gottfried Leibniz back in the 1600s. And he goes, anytime you see something happen, there has to be a sufficient cause for it. There has to be a reason for that. Either an efficient cause or a first cause. There has to be a reason for it, right? That's sufficient to explain what you see. Now, what we see is a non-physical cause, massive, rapid event, an expanding universe, and quick progression. That's what scientists observe. That's what they all say is happening or has happened. Gerald Schroeder then says, okay, guys, we got to admit this. MIT-educated physicist. He goes, look, the physical system we refer to as our universe is not closed to the non-physical. It can't be closed. Its total beginning required a non-physical act. So everything physical came from the non-physical, and they obviously have no clue as to how that happened. But they know that the physical came from the non-physical. Lawrence Krauss said, again, intellectually honest enough to say, look, we can't rule out the logical necessity of a first cause. Okay? Logically, something should have caused the universe. He doesn't want that cause to be God, but he can't rule God out. And then finally, let's go back to Gottfried Leibniz. This is one of his big hair days. And Gottfried said, for one being dominating the universe not only rules the world, but he creates and fashioned it for the sufficient reason of existence. There's got to be a reason for us being here and for the universe being here. The sufficient reason of existence can be found neither in any particular thing nor in the aggregate, the whole aggregate or series. And I think this is interesting because guess what? What we observe scientifically, is literally what the Bible has been saying for thousands of years. God is spirit. God created everything from nothing. God stretched out the universe. He suspended the earth over emptiness, and the universe is going to end. And a lot of scientists said the Bible is nonsense because how could the universe end? It never began. Well, gee guys, it did begin. And so it can end. It couldn't end if there was no beginning, but there was a beginning. So what would the principle of sufficient reason suggest for all this? Okay, I leave you with that question. Now we look at the next piece of evidence. Not only did the universe begin, but it has extraordinary qualities. Now, if you were to look at something in this room and say, hey, somebody designed that, normally what you would say is it's organized, it has standard components, standard forces, standard construction, consistent operation, it looks precise, okay? It's intelligible, it's beautiful, there's complexity, progression, and it has a purpose, an evident purpose to it. Those are some of the things that would cause us to conclude that an automobile was designed, that an airplane was designed. And guess what? That's the way the universe looks. Okay? At the largest scale of the universe, and this is according to Paul Davies and Freeman Dyson, both physicists, and he's a deist, he's not a Christian. I think he's a deist, he may not even be a deist. He said, instead of finding that space is filled with a dog's breakfast of unrelated bric-a-brac, astronomers see an orchestrated and coherent unity. On the largest scale of size, there's order and uniformity. And then Dyson went on to say, look, the universe looks like it was architected. So when you look at the universe as a whole, what you see is coherence, architecture, and order. And those are qualities that you would normally think are consistent with the design. Okay, that's at the big, big scale. Now let's drill down into the weeds. At the small scale, it looks designed too. Okay, now Frank Close's physicist, he said 100 years ago, atoms were thought to be small impenetrable objects like miniature versions of billiard balls, perhaps. Today, we know that each atom has a rich labyrinth of inner structure. It's actually probably 150 years ago when they believed this, but close enough. And in fact, what you see in every atom, incredible organization, okay? Incredible organization. Okay, you see, a proton has 2 up quarks and 1 down quark, and gluons. And each quark has 1 of 3 different color charges. Neutrons, 2 down quarks, 1 up quark. Gluons with different color charges. And then mesons to help hold it together. You have boundaries and limits, so the Pauli exclusion principle means that electrons can't share the same quantum state. That way they're not banging into each other. And that's where you have different levels of shells and electrons that basically it makes chemistry possible as we sit in the dark. Wonder why that happened. And then also I think it's interesting that, okay, the maximum, in an atom, you have different shells of electrons, right? And the different layers is what makes chemistry possible. Okay, and it's interesting because every electron has exactly the same mass. If it didn't have the same mass, you couldn't have molecules, which I think is interesting. And also, there are rules on how many electrons can be in each shell, and the rule is 2 times n squared. Who thought that up? How could there be 2 times n squared electrons, and that's for every atom, for every molecule, everywhere? Then you have standard components. So if I'm building a house, I get PVC pipe, there's building standards, I get 2x4s, 16 penny nails, shingles, I have all of these components and they're standard components, right? That's what you see in every atom. So for example, let's take an up quark. An up quark has a charge of positive 2/3, a mass of roughly 2.2 mega electron volts over the speed of light squared, a spin of a half, and a red, green, blue color charge in every single one. A down quark has a charge of minus a third, a mass of roughly 4.7 mega electron volts over the speed of light squared, a spin of a half, and a red, green, blue color charge. It's like, these are like standard components. This isn't a mess. This is incredible construction, incredible standardization of components, and guess what? Incredibly precise. And just for example, there's about 30 knobs, okay? There's 26 fundamental constants, but there's about 30 knobs in total where if you altered it just 1%-ish, the universe wouldn't exist as it currently does. We would have no life. Out of 30 knobs, all of them have to be precisely fine-tuned. So, and this blows physicists' minds. So Richard Feynman, Nobel Prize winner, said about the fine structure constant, it's one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man. You might say the hand of God wrote that number, and we don't know how he pushed the pencil. Because guess what? The numbers just are what they are. They are what they are. And if they were slightly different, we wouldn't be here. Then you have laws and consistent operation. You have standard forces. When the universe began, there were 4 standard forces, not one. Okay? In the 1800s, they thought that there were 7 forces that all originated in one primeval force. It wasn't. There's 4. 4 different forces. How could there be 4 forces, all of which do specifically different things, incredibly different things, all at the moment of the Big Bang? Progression and purpose. You know, Arno Penzias, who discovered one of the discoverers of the Big Bang background radiation, he basically said that the universe looks like it was created to support life, as though that there was a whole supernatural plan for this. And then finally, intelligibility. Einstein was absolutely blown away because how could all of this be intelligible? How is it that we can even understand it? This one, most of us don't think about. But when the universe began, guess what? It came with a language. It came with a language, a physical language, and we call it mathematics. And Paul Dirac, who's a Nobel Prize winner in physics from England, said, "It seems to be one of the fundamental features of nature that fundamental physical laws are described in terms of a mathematical theory of great beauty and power, needing quite a high standard of mathematics for one to understand it." You may wonder, why is nature constructed along these lines? One can only answer that our present knowledge seems to show that nature is so constructed. We simply have to accept it. One could perhaps describe the situation by saying that God is a mathematician of a very high order, and he used very advanced mathematics in constructing the universe. Now, would you expect that of a random, accidental universe? And one of the physicists we're going to talk about later went from becoming an atheist to becoming a believer in God, ultimately a Christian, while he was studying his first particle physics class. Because he looked at the math, and the beauty of the equations literally brought him to tears. And he wept in class because he was just so blown away. How could the math of the universe be so beautiful? And his conclusion was, there has to be a God. The math can't be that beautiful without a God. And not only is the math beautiful, it's like none of this had to be beautiful. So, is this a recent phenomenon? No. Guess what? The universe has always been this way. And we know that because Roger Penrose, again, Nobel Prize winner in physics, one of the greatest mathematical physicists that the world has ever seen, said, the precision needed to set the universe on its course is seen to be in no way inferior to all that extraordinary precision we've already become accustomed to in the superb dynamical equations, Newton's, Maxwell's, Einstein's, which govern the behavior of the things from moment to moment. But why was the Big Bang so precisely organized? And then Frank Close, another physicist, said, as the universe aged, it cooled at first very quickly. Within a millionth of a second, quarks clustered together in threes where they have been remained ever since. Within the first millionth of a second, there was structure and order and construction in the universe. Precise laws of entropy built into the universe. It's like it has always looked organized. It has always looked designed. There's never been a time when it didn't. Okay. Why? Why? Is it because does all this exist reasonlessly and without a purpose, as Stephen Hawking believes? Or is it because for a reason and a purpose, like Owen Gingerich at Harvard astronomer believes? Who's right? Hawking goes back to his multiverse idea. You know, the idea is because there's one universe that looks so incredibly designed, there must be an almost infinite number for our one universe to look like this. Guess what? There's a couple of problems with this. The first problem is we've never observed another universe. We see no universes popping into or out of existence. Okay? If there were other universes, guess what they would have to have? They'd have to have a collision prevention feature built into them, or we'd be bumping into them all the time. And then you would have to ask who invented the collision prevention feature, right? And there's all kinds of logical absurdities. So if there's an infinite number of universes, there's an infinite number of you. Okay? One of them would be 7'8" tall, you'd be a great golfer and a ballroom dancer. Okay? The logical absurdities are incredible. And the other thing is, if there's an infinite number of universes, there would be a universe where you had godlike power. Okay? Then they also go, wait a minute. If there's an infinite number of universes, why do you assume that this infinite number of universe generator would generate different universes? Why would it not generate the same kind of universe? You see the logical absurdities? And then, bless his heart, Victor Stenger likes to live in denial. He's going, hey, the universe doesn't look designed. Then you have more beginnings. You have life from non-life. And this is a pretty mind blower because, you know, guess what? And Francis Crick, who discovered the DNA double helix, you know, he said, an honest man armed with all the knowledge available to us now could only state that in some sense the origin of life appears at the moment to have been almost a miracle. So many are the conditions that have to be in place to be satisfied to get it going. Okay, and this guy is funny. You've heard of Richard Dawkins, right? Okay. Richard Dawkins, he's a biologist, big into evolution, okay? But he observes that there's about 10 million species on the planet. How many of those 10 million species look designed? All of them. Then he says every organ within every species looks designed. So wait a minute, Richard. So you're saying 10 million species, every organ within every species, so if there's like 10 organs in every species on average, that's a ratio of 100 million to 0, right? Because none of them don't look designed, according to him. But he goes, but they weren't designed. It's just an illusion of design. James Tour, he's a synthetic chemist. So the unique thing about synthetic chemistry is they study inorganic things. So he would know a lot about how to try to get something inorganic to become organic. And his comment is, try as they might, without pre-existing life, no researchers have ever seen molecules assemble into a living cell or anything even remotely assembling it. And one of the challenges that he points out, do you know what the first cell had to have in it? 4 classes of molecules. The very first cell had to have nucleic acids, amino acids, lipids, and carbohydrates. 4 different kinds of molecules, not 1, 4. The very first life cell also had to have 5 processes. Okay? It had to be able to assemble a membrane, energy extraction, protein synthesis, DNA replication, and cell division. And if it didn't have that, there would not have been a second cell. Okay? The very first cell also required complex structures. He said it was roughly 40,000 lipids in a cell membrane. Whoa. And there's differences in the inner membrane and the outer membrane. And of course you have DNA and RNA, okay? So the human genome has what, 3.1 billion characters of information, if I remember correctly? And then you had to have purposeful information, which for the simple bacteria would require 256 protein coding genes. And you would have to have very quick assembly. As a matter of fact, he says most of these chemical reactions, he goes, most of these chemical combinations degrade within 2 weeks. So what he is saying is, this is extraordinary, and this is why Francis Crick said it looks like it's practically a miracle, because you would have to have 4 classes of molecules, 5 processes, complex structures, purposeful information, and you would have to put it all together fast, really fast, within weeks, or these chemical reactions break down, okay? Now, if I see a complex transformation of very disparate things into something totally unique, and I see complex structures, rapid assembly, what would that normally tell you? Okay, have any of you ever seen played with Legos? You know, and you buy the Legos and it has the really cool picture on the outside, right? Okay, and you go, hey, I wish all these Legos would just kind of turn into that thing, okay? And you take all these standard components, okay, and you try to turn them into something that's even not alive, right? It takes a lot of work, right? To take standard components that are disparate and put them together into something new. You don't really call that intervention. And then you have purposeful information from non-intelligence. And this is one of the things that blew Gottfried Leibniz's mind. He could not believe that you could get intellect from non-intellect. Okay, you can't get intellect from a rock. And one of the they call it the consciousness problem, okay? And one of the big things about the consciousness problem, and it's also an information problem, is they're basically saying now, some people are calling it that the universe matter is imbued with information. Go, wait a minute. Matter is imbued with mind. And the reason that they're saying things like that is, how can you get intelligence from non-intelligence? Well, maybe you should look, instead of to an intelligent rock, someone who's intelligent enough to make a rock. So, and this is just a quick quote. This was published in The Progress in Biophysics and Molecular Biology, for those of you who are biology majors. The transformation of an assemblage, of an ensemble, of appropriately chosen biological monomers, amino acids, nucleotides, and the other 2 types of molecules that I mentioned, into a primitive living cell capable of further evolution appears to require overcoming an information hurdle of super astronomical proportions, an event that could not have happened within the time frame of the Earth, except, we believe, as a miracle. These are scientists saying this. Purposeful information suggests intent. So, if you had two choices, what's your choice? What caused nature's beginnings and apparent design? Because there wasn't just one beginning, there's beginnings. The beginning of the universe, the beginning of life, the beginning of consciousness. There's all these beginnings, the beginning of information. Okay? Did it come from non-intelligence? For no purpose? Out of nothingness? Or did it require intelligence, purpose, ability, and a decision? I think Owen Gingrich's comment is kind of interesting. Again, he's a Harvard astronomer. He said, to me, belief in a final cause, a creator God, gives a coherent understanding of why the universe seems so congenially designed by the existence of intelligent, self-reflective life. And I think what's really interesting to me is these are world-class scientists. Okay? World-class science and belief in God are not inconsistent. These are world-class scientists. But they acknowledge that there's a limit to what nature can do on its own. And all of these people used to be atheists. For these people, science illumined nature and nature pointed them to God. So, Alan Sandage is generally considered the second greatest astronomer in the 1900s, second only to Edwin Hubble. At 50 years of age, he concluded that there is a God, there must be a God, and the reason he concluded that is the Big Bang. He said that the only way that this could happen is if God did it. You can't have a beginning without a sufficient cause. Antony Flew is a philosopher. He basically he called himself the most notorious atheist on the planet for about 50 years. He authored the most quoted atheist essay for literally a 50-year period of time. It's called Theology and Falsification. At the age of about 80, he changed his mind and said God does exist. And the reason was purposeful information in DNA, programs in DNA, the beginning, the fine-tuning of the universe, and the way he describes it is, I didn't have any spiritual crisis. I wasn't even looking to the spiritual. I made a conclusion based upon where the science led me. And science led me to the belief in God. Richard Smalley, I don't know his whole story, Nobel Prize winner in chemistry. Again, it was science that led him to God. Fred Hoyle was an agnostic. And again, for him, it was atomic mass 5 being unstable. And because atomic mass 5 is unstable, guess what? You get a whole lot of atomic mass 12. Because it's unstable, it gives atomic mass 12 time to develop. What's atomic mass 12? Carbon. We're carbon life forms. And he's going, all these other masses are stable. Why is 5 unstable? If 5 were stable, we wouldn't be here. And his conclusion was, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as chemistry and biology, and there are no blind forces worth speaking about in nature. And now the last guy. This is Christer Renard. He's a Swedish physicist. Okay. Sweden is not a particularly religious country, right? This is the gentleman who came to tears while studying particle physics because the beauty of the math. And his conclusion was, I found that the laws of elementary particle physics, they were like, this can't be just randomness. A chaotic system can't have so beautiful laws. So actually it was science that drove me to God, because I realized that there must be something behind everything. It was the beauty of math and particle physics. But you know what? Science isn't the only thing that illumines the world around us and leads us to God. Edward Fesser was an atheist philosophy professor. Philosophy led him to God. Sarah Salviander was an atheist astrophysicist. Morality got her interested, and then the consistency of what she read in the Bible and science got her over the hump. Same thing for Francis Collins, who's the head of the National Institutes of Health. History with Ian Hutchinson. He read about the life of Jesus, and the historical evidence for Jesus blew him away. Jesus was not a myth. The same thing happened for Michael Guillen, who's also a physicist. It was the historical evidence for Jesus. I'm going to conclude with these ideas. Remember Gottfried Leibniz, principle of sufficient cause, principle of sufficient reason. In the 1800s, he looked at the evidence that was available, and he concluded, based upon nature, what God must be like. And he concluded that God had to be eternal, very powerful, self-sufficient, all-knowing, had to be a being, not just a thing, perfect, infinite, and loving. Guess what? Antony Flew, a few hundred years later, looking at science, looking at nature, reached almost exactly the same conclusions independently. And he said that God must be self-existent, immutable, immaterial, omnipotent, omniscient being, eternal, and purposeful. And guess what? This is what the Bible has been saying for thousands of years. It's exactly what the Bible's saying. The Bible talked about God's metaphysical attributes, his omnipotence and all that, and his personal attributes. Nature tells us a lot about God's metaphysical attributes. It tells us less about his personal attributes. Where do you go to find out about God's personal attributes? That base of knowledge is called revelation, not science. And you find that in the Bible. And that's where you look at Jesus' life. That's where you look at God's interaction with human beings. And then you reach your own conclusions. So for a couple thousand years, actually this is probably King David, this is about 1000 BC. King David said, "The heavens declare the glory of God. The skies proclaim the works of his hands. Day after day they pour forth speech, night after night they display knowledge. There's no speech or language where their voice is not heard. Their voice goes out into all the earth, their words to the end of the world." So even King David was saying that the universe declares design and construction, language, intellect, and information. So I invite you all to investigate the rest of the story.